ワンオンワンテック始まります。今日のテーマは AI はアメリカ製だけでいいのかです。OpenAI とかアンソロピックなど今 AI スタートアップは業界の頂上決戦を繰り広げています。そして AI を取り巻くお金と権力がこの2社にめちゃくちゃ集中し始めています。AI はアメリカ製だけでいいのか、開発者が一握りの企業だけでいいのか、あるいは巨大な LLM だけでいいのか、こんな問題意識のもと日本で立ち上がったのが AI スタートアップのSakana AI です。今日は創業者のデビッド・ハー CEO に来ていただきました。デビッドさんをご紹介する前にトピックは3つです。全知全能 AI へのアンチテーゼ、そして AI が AI を作る時代、最後が AI 企業の勝ち筋モデルということで、デビッドさんをお呼びしましょう。We're joined by David Howe, CEO of Sakana AI. Thank you very much for taking the time.
Right. Thanks for having me here, Nakagawa-san. It's truly an honor.
It's great to have you here. First, I want to ask you about your journey leading up to founding a company. And you started a career at Goldman Sachs and then became an AI researcher at Google Brain, which is now Google DeepMind. So could you tell us a little bit about your journey leading up to now?
Sure, thanks. It's really kind of a weird and incredible journey. I founded this company, Sakana AI, now relatively well known, but I'm not a Japanese person. I'm a foreigner that started this.
And where are you from originally?
I was from Canada.
Canada, okay.
Canada. And, I've never thought that I would end up starting a company in Japan working on AI. So this is a kind of a weird path. I studied in the University of Toronto. Studied neural networks. It was kind of near the AI winter, so no one really cared about the neural networks. But in my undergraduate studies, I actually worked on the neural network algorithms. After I graduated, the economy was not doing so well. I couldn't really become a researcher, so I actually joined the finance industry. I worked, for several different institutions, and I was recruited by Goldman Sachs as a derivatives trader. And this is how I came to Japan. Back then, Goldman Sachs headquarters was in Tokyo, in Roppongi Hills. So I decided to join them and come to Japan and started working right around the Lehman shock.
That was a crazy start.
It's a crazy start, right? It makes you learn a bit around that time. And that kind of formed some of my skills and my philosophy. In a few years after I joined Goldman, I started reading up on AI again. Back then, actually, Google started publishing some incredible work on deep learning. I was kind of, in some ways, obsessed about learning about AI. So whenever I have a lunch break or after work, I would read AI papers and actually do some of the research myself. I had a blog back then, like an anonymous blog called Otolo.net. So now Sakana AI, before it was Otolo. Otolo.net, like a switching there. Right? And I started publishing some of my work there. And some of those works became well known. They were on Hacker News, in the Y Combinator's website. And people didn't know who I was at the time. But around 10 years ago, because many of these works became well known, some folks at Google actually persuaded me to apply to work at Google Brain as a researcher. So I decided to apply to work at Google. Google Brain is now Google DeepMind. And I decided to leave the finance industry and actually leave Japan to move to California to work for Google as a researcher.
Oh, you first joined Google in California?
Yes, in San Francisco. It was a very difficult decision because I really loved living in Japan. I had to give up my gaijin card or the residence card the first time. So, when you leave Japan, they would, the Narita airport would poke a hole in your residence card. I cannot come back using that card again. And I moved to San Francisco. But I had an incredible time at Google. It was a great time to learn, to join deep learning research community in 2016, around 10 years ago. My focus at Google was to work on what we call generative AI. I worked in...
That was really early, generative AI.
Yeah, right? It's not the earliest, but it was when there was the inflection points. I worked on several things. One of the works that I was proud of is called World Models. So I collaborated with a professor called Jürgen Schmidhuber to actually modernize the concept of world models, getting these models to work on videos, on video games. The agents can actually use these models to learn policies inside their own hallucinations. Another work I worked on is on the creative AI elements. I worked with my collaborator and manager, Doug Echtime, who you might have met before. And we actually worked on algorithms like language models applied to creative domains, like sketching. And the theme of our work is always trying to create models that can create innovations, whether it's new type of sketches, new type of algorithms, using relatively minimal resources. And back then at Google, there was an opportunity to return to Japan, actually. Because Google actually did, they had an Asian expansion strategy, but it didn't really work out in China, as you can imagine. But Japan is a great market for Google. So basically, I talked to my boss, Jeff Dean, at the time.
Jeff Dean, Chief Scientist
at Google now. And I convinced him to let a few of us relocate to Japan to start a research team in Japan. So I had a great opportunity to come back to Japan one more time. I got a new residence card. And we're able to continue the direction of creating new generative AI models, new creative AI models, and we're able to also work on evolutionary optimization algorithms, harnessing creativity and energy efficient technology into building the space. And around the time, I was there for around 6 years or so, and I think it was really the time for me to try to start a company. I started thinking about starting the company in AI. I think, I was a bit concerned that much of the AI developments is done in US, which is the theme of this interview, or in China. And I'm not a Japanese national myself, but I love living in Japan, the culture here and the values. And I think, it would be a shame if AI development progressed without any input from Japan. So I wanted Japan to be part of the global conversation of AI developments. And here we are with Sakana AI. So what do you think?
It was a pretty interesting journey, But Sakana AI is the mixture of the Japanese and English word, and you didn't name it in English. And so I was wondering why you named this company Sakana, and what was the thinking and vision behind it?
Yeah, this is a good question. I'm also a practical person as well. When we looked at the names, what I did was I looked on the internet registry to see what's available. I wanted to find a name that sounds like it was the origins is in Japan, but at the same time, people, especially foreigners, can read the name. Right? So we cannot use the letters with the word R or difficult things that have different pronunciations, right? And Sakana.ai was available.
Domain was
registered for 2,000 yen. So
2,000 yen.
I registered it from Namecheap.ai, and I talked to my co-founders at the time. We had a vote, and I think the Sakana itself means fish, right? So a lot of our research work is related to the concept of collective intelligence. You can have many different fish swimming together, or another way to say it is intelligence is not just an individual fish, but it's the group, the school of fish is the intelligence.
What's collective intelligence? What does it mean?
So one of the founding beliefs of our company, especially when I started, is it's a bit contrarian. Like the world is moving towards large monolithic models of AI.
Like GPT or Claude or Gemini.
Or even before Gemini at Google, everyone's working on large models. And these, I can see back then that these are going to require extreme scale of resources, energy, data, and whatnot. And I think, I believe that there should be an alternate path of achieving strong AI. I think like in humanity itself, our intelligence is a collective intelligence. The human AI is not just what's in here. It's not just what's in your brain, but we have like billions of brains, or we have a culture. Everyone's working together to form collective human intelligence. And I believe the same is for AI. I think in the end, no single AI model or technology will win. Every model is trained or developed for its own purpose, has its own strengths and weaknesses. And I believe that's like the building the systems that can harness the power of several different AI models would ultimately achieve not only higher performance, but also help achieve more structurally reliance of AI. There's a concept of dependency, whether you don't want to be tied to a single particular AI model or a single particular vendor. And I think developing AI based on a collective intelligence systems is the right path forward. And I believe Japan's the right place to build this technology, because like Japan is a place of limited resources.
Right.
We don't have as much resources as China or the US. But however, I think just like how innovation thrives on limited resources, like the saying goes, like the mother of necessity is
right.
So I believe that's Japan. Having this lack of resources is actually the right place to build this technology. Japan also has the history of doing this as well. If you look at the history of Japan, you have some of the most innovative companies from the 80s and the 70s and 80s, like the Sony and the Hitachis and the Panasonics. They thrived not because Japan had lots of resources, but because of a lack of resources, they have to continuously improve. And I believe that's in our company, we also strive to build the AI technology that can also help this innovation continuously improve, even on the process of AI research itself.
Was that what you realized when you were working at Google, even though they're working on the single, like massive models?
Yeah, well, Google is an interesting place. It's a huge company. Google is now working on large, massive models, but also there are many people inside Google who really appreciates energy efficient or like constraints-based research. When I was at Google, our group worked on small models that can be very creative, that can draw new things. Like we had a product called AutoDraw that was powered by Sketch RNN. Even today, Google works on Gemini model, but they also worked on the Gemma models, which is kind of a smaller variant of that.
That can run locally on device.
Exactly. Yeah. And I think like this is pretty important. I think there's a place for large monolithic models, but there's also a place for small capable models that can run on devices.
But so I was wondering what Sakana AI is actually trying to build.
Yeah, I mean, we are not a Japanese OpenAI. I think like Anthropic, OpenAI, and Google, they're building large monolithic models. The core focus of our company is building collective AI systems. Systems that can orchestrate multiple different AIs to either get better results or better AI sovereignty. I'll give you a few examples of what we built or what we're building. On the product side, we are releasing a product called Sakana Marlin. It's based off our ABMCTS technology, like adaptive branching Monte Carlo tree search, where our algorithm, due to the inference scaling principle, can combine several different foundation models to achieve like a really deep research. These autonomous agents would run for 8 to 12 hours to compose like the research documents or strategy documents that might take human teams like months to produce. And it can do it within 8 hours. Another technology we released is called the Sakana Fugu model. It's a frontier model based on our orchestration technology. Fugu is an LLM, but it knows how to orchestrate between different frontier LLMs in order to achieve higher results.
Between GPT, Claude, Gemini, and other models.
Yes.
And it itself has an LLM.
Yes. So the Fugu itself is a small LLM. Think of it this way. If you are an AI engineer these days, you at your disposal, you may have access to several different LLM, whether it's DeepSeek or whether it's Claude, GPT, or Gemini. And heuristically, as an engineer, you might know the strengths and weaknesses and the costs of each of these models. Right? You know that maybe the open models are cheaper but less performant. You know that Claude is good at coding, GPT at reasoning, and Gemini at creative writing. And if your boss gives you a task to build some product or workflow, you will use your heuristics to mismatch this web of models using something like LangChain or something. But I feel like in the history of AI, any heuristics that kind of exists with our human discovery will probably be learned using machine learning. And when we developed this Fugu technology, I think we were one of the pioneers of the RL-based orchestration technology. We use a method called reinforcement learning to actually learn end-to-end what the task is and which models to send the task. I think this is an important technology because we're not simply routing the task. When modern LLM systems have multi-step reasoning, at every step of this reasoning, our Fugu model would also decide based on the feedback which models to then send the task to. So we're really scaling the concept of inference time scaling. And we think our results of this technology is we're able to get state-of-the-art results above any of the individual model. This is not a surprise to me because it's like if you assemble a team of Avengers, that team will be better than the individual heroes. The same with model orchestration. If we have an assembled team of different models, some of them are good at some things, some of them are bad at other things. You're obviously going to get much higher performance above the entire group. And I think this technology is relevant for AI sovereignty as well, because one of the characteristics of our technology that we're developing is the concept of self-reliance. If any of these models get turned off, it will still continue to work. The model will dynamically route to other models in the pool. And I think in the competitive landscape, especially global competitive landscape of AI, every week you have new models coming out, new companies coming out, new small models, big models, some models that are good at math, some models are good at coding. And I think having a company like ours really focus on developing the expertise to train orchestration models is an important technology for for the future of AI.
Right. You're seeing only a handful of companies have the most powerful models in their hands, and do you think the concentration of power concerning for the future?
Yeah, this is a concern of mine. But firstly, I do respect the progress that's being made for monolithic models. At Sakana AI ourselves, we use many of these frontier models ourselves. We are not competing against these models. And I think my concern is not on the performance per se, because we know that's the rest of the world. It's only 4 to 6 months behind the frontier. Historically has always been this way. I'm not concerned about Mythos or the crippled version they have now is above the performance. I'm more concerned about the structure of dependency, and I think the answer to that is collective intelligence-based systems, because if we have access to several different models from different vendors and different countries, this dramatically lowers the risk of this self-dependency. If one of the vendors decide to shut off the models to Japan, it's even a case supporting how important it is to build up this supply chain of models to maintain this self-reliance. So we've been developing products based on collective intelligence systems like the Sakana Marlin and Sakana Fugu. We ourselves also develop LLMs ourselves. We develop a series of LLMs that we call Namazu, like a catfish.
Right.
And also we released that model on a product called a Sakana Chats that's available in Japan. For this particular model development line, we actually don't train the model, a large monolithic model from scratch. And instead, we looked at frontier open source LLM models, such as, for example, there's a DeepSeek model. We chose that because it was developed in China and is actually one of the most biased models.
Oh, is that why you chose DeepSeek?
This is one of the, it's a bit controversial, but this is one of the reasons we chose this direction, because we chose 3 models. One is a DeepSeek, one is Llama 3.1 405B, and one is GPT-OSS. For us, we wanted to build the post-training technology that can take models developed all over the world and align them to Japanese standards.
So, Japanese standards, what does it mean?
Exactly. So Japan's specifications. So let me explain, because I think there's many open source models developed around the world, and a country like Japan, even in the US, everyone is using open source models to develop their products and their R&D. But I don't think Japan, many companies in Japan would simply take a model developed in the US or China and adapt them right away in Japan. There's many goals in our post-training technology. One is to reduce the censorship of the models. There's also, because these models, if they're developed in China or the US, they have their own cultural biases. The second part is to align them to be neutral to Japanese values. I'll give you an example. For some of these models, when we question them on Japanese politics and Japanese history, these models would actually not respond 70% of the time.
The DeepSeek?
Like a DeepSeek or even Llama. They would refuse to give you the answer because of the post-training that they've applied to these models. Right. So
to make it politically correct or something?
I mean, every country has their own narrative.
Right.
But for what we've done in our post-training is to get that down to close to 0. So it would actually give you an answer that we believe is the most neutral answer, and it will give you the answers based on Japan's history. So this is actually quite a challenging process. Not only do we have to uncensor the model, also debias the model. We would also have to post-train the model to learn about Japanese culture and history. And the fourth part, the last part, sorry to take your time, but the most difficult part is how to preserve the original performance of the model.
Right.
Because there's a concept of LLM training called catastrophic forgetting. Once you start continue pre-training or post-training the model, it forgets its original ability. Right. So you have like a 500 billion weights of your neural network. When you're training it about Japanese culture, it might forget how to do math. Right? So it's not like the humans.
Right.
And while doing all of the 3 points above, we have to continue having its core reasoning, math, and coding skills. So we refined this technology and we showed that it works across DeepSeek, one of the most biased models, because we want to show that this technology can be applied to one of the most biased models out there rather than the neutral model. We found that Llama was actually quite biased as well. It's produced by the US and there's their own narrative. And we also applied this to GPT-OSS, which was kindly released by OpenAI. And that model was actually not so biased. So we showcased our Namazu LLMs based on this post-training technology. So what we did is we released Sakana Chats. It's not simply an LLM. It's an LLM with a web search agents. And it has reasoning capabilities as well. So anyone in Japan can use Sakana Chat to ask anything. And rather than hallucinate, it would first call the web search agent to collect like the actual factual data and structure the response in a way that's, I would say, aligned with Japanese values and culture. We've even moved to the extent of adding several different modes into Sakana Chat. There's the polite mode, which I had to learn because, it's as a foreigner, it's hard to learn about keigo and, like a normal speech. So this is one example of collective intelligence using different models around the world for Japan. And I think, we're continuing that front. And I guess the last R&D direction that we're really focused on is in AI-driven discovery. We're one of the first companies in this space to explore the concept of recursive self-improvements with LLM technology.
Right.
So since 2 years ago, we started figuring out that LLMs can generate new ideas, and maybe these ideas can lead to new AI innovations itself, and that led to all sorts of innovations like ALE agents, Shinka Evolve, and most recently the AI scientists as well.
Right. Okay. I want to touch on the RSI in the next part, but before moving on, so the OpenAI, the AI labs like OpenAI, Anthropic, they have much focus on pre-training phase of AI development. Like when you look at the development process of AI, the pre-training, post-training, and inference. So you guys put more priority on post-training and inferencing. So is that because those process have use much less compute or able to do those with much less resource?
That's a good question. You're right. Our emphasis is on post-training and scaling up inference time. We think we want to do this for several reasons. The majority of the labs are focused on pre-training. Someone needs to focus on developing the post-training and scaling up the inference time research. Another reason is we believe that most of the capabilities to be unlocked in this AI technology is from post-training and also in inference time. To give you an example, like let's step back 2 years, 2 to 3 years from now, before this time. When say OpenAI or Google or anyone started scaling these LLMs, it was apparent that these systems cannot really reason. There's a benchmark called ArcAGI. This is a puzzle where it's a graphical puzzle that elementary school kids can easily solve. But state-of-the-art LLMs would get like 1% of those questions correct. It's because there's no reasoning capabilities at the time. And once we start scaling inference time by even a little bit, if we add in an inference step on the reasoning, it's able to suddenly solve 50% of the ArcAGI problems. And we believe that's the intelligence is like the scaling up the inference time. Our lab has even taken this to the extreme when we developed the ABMCTS method, where we're scaling up inference to run for 8 hours or 12 hours, where all of those inference are accounted for to produce very high quality reports. Also, the AI scientist is another example of scaling up inference, having these agents come up with ideas, write out the workflow themselves. And post-training, we applied that to develop our Namazu LLMs, which can be applied to Sakana Chat. So our lab is primarily focused on post-training and also on the scaling up inference time. But at the same time, we believe that once inference time scaling enables RSI using our AI scientist technology, we're applying this technology also in pre-training phase itself, creating energy efficient, smaller, agentic native models. And actually, that's actually something in our pipeline for the next 12 to 18 months. We are starting to develop our own pre-trained models from scratch.
One last question before we move into the next part, but Sakana AI has attracted major investors from Japan and overseas, respectively, like NVIDIA, Google, like Khosla Ventures or NEA, or other Japanese giants like MUFG, NEC, and other companies. So what do you think they are betting on? The technology or the team or business model, or what do they talk about with them?
I think depending on many things, but primarily the world or the investors believe that there's a path towards AI development that's not US-centric. For us, having a world-class R&D team in Japan, developing solutions in Japan for Japan, clearly meets a market demand, which is for sovereign AI in Japan. So because of the sovereign AI needs, there needs to be a path in Japan to fulfill that. The second part is our energy efficient R&D direction also has economic value as well. It addresses concerns that affect not only Japan but globally, like the data center crunch, even like the RAM shortage. Being able to develop energy efficient AI systems would have a global need. So the fact that NVIDIA and Google has invested in us, these hyperscalers, also show that even the core players wants to invest in this technology of energy savings and energy efficiency.
Did you talk to Jensen or Demis?
We had to pitch to Jensen actually last year. Yeah, that was.
How was it?
That was quite an experience. He's a fantastic guy. He actually took us to have dim sum when he was in Tokyo. We talked a lot about how this technology can grow in Japan, and I think Jensen also really wants to see AI development succeed in Japan. One of his earliest customers were from Japan, and I think they're working on supplying the not only the raw like GPU and computes for Japan's needs, but also trying to build the ecosystem here in Japan as well. So for us, we also have many collaborations with NVIDIA. We work with NVIDIA on developing a new sparsity formats specifically tailored for NVIDIA's hardware that can lower the training costs by, depending on the scenario for the LLM, by like 70 to 80%. And this actually has been published paper at the iClear conference a few weeks ago and started to be like and it's a collaboration between the NVIDIA researchers and Sakana researchers. Some of the NVIDIA researchers are also based in Japan as well. So it's really an honor to be able to have an investment from NVIDIA, but more importantly, work together on making more efficient AI, particularly for NVIDIA hardware, which powers the world's AI systems.
Okay, let's move into the second part, the era of AI building AI. So you mentioned several times about AI scientists that the Sakana AI's research, and I think the most well-known projects among Sakana AI's projects, but it's published in Nature back in March this year. And so what is this AI scientist? Is it part of the ambition of making AI, building AI?
We started exploring using LLMs to create new scientific ideas back in 2024. One of the original papers we published is called the LLM Squared, our blog post, where we have an LLM discover new LLM training algorithms. And that led us to scale up this idea into the AI scientists. The AI scientists, I would say, when we started working on this, it was still ahead of its time. The concept is having a system of agents powered by LLMs that can conceive of new scientific ideas, in particular AI ideas, AI machine learning research ideas. And not only does it have to produce these ideas, it actually write the code to run experiments to verify these ideas. It will also have to collect the results from these experiments and eventually compile a scientific publication and also review its own paper. 2 years ago, the foundation models and this technology is still very immature. When we first showcased it, just like any new technology, it's full of problems. People were misciting papers. These agents were citing a paper from one researcher, but when it should be attributed by another researcher. The experiments were not so novel. The results were flaky and not so innovative. But over time, we showed that this technology can be improved, either with better models or with better processes. And I'm quite proud that we're recognized as one of the pioneers of the AI scientist technology. And as a researcher, it's a proud moment to have this research showcased in Nature Journal, the top scientific journal in the world. It may not directly make our company revenue, but I think it's important for a company in Japan, an AI company, to be able to produce the AI R&D that can be showcased internationally in a venue like Nature.
Right. Okay. And I think you talked about it, but there have also been critical independent evaluation of AI scientists, like weak novelty assessment, coding errors, or hallucination. But you already addressed them, and how is it?
Even though I addressed them, there's still a path ahead. So I want to emphasize that the AI scientist paper in Nature itself, AI scientist itself is not a Sakana AI product. We want to document the current states of AI-driven discovery. We also want to document the limitations of this technology. Because we envision that's like the process of science itself. Even outside of AI science, scientists will or probably start using AI right now. AI is going to help co-create new discoveries and new innovations and be part of the scientific process. And the purpose of our Nature paper is to document the current state-of-the-art capabilities in AI scientists. And we also very carefully wanting to address concerns we have about how the community needs to have a strict ethical guidelines to incorporate AI-driven research into actual research. So, for example, we as researchers, when we submitted the AI scientists produced papers into the iClear workshop, we actually got permission to do that at first from the organizers. And even after the paper had a high acceptance score, we agreed to withdraw the paper from publication because we think that the AI research community has to set the guideline as to what and to how, to the extent AI-driven research should be published. So we have to make sure that all the citations are checked. We have to make sure that all the prior work are addressed. And at the end of the day, this applies beyond AI scientists. Like there are jobs and there are tasks. I believe that as humans, we are given the jobs as a scientist or as a researcher, and many of the tasks can be augmented or automated using AI. But ultimately, a human in the loop, as part of the process, has to take responsibility for the publication.
So, even if you can run AI scientists, you think the human in the loop is needed. So, where do you think is the future of like scientific research going?
So my view is humans should be in the loop. This is my view. And this is a very complex question. The reason why I think humans should be in the loop in RSI is multiple-fold. One is the current state of technology is not perfect. As you highlighted, like the AI scientist has many flaws, even when using frontier models. We should at least have a human check the results before doing another self-improvement in RSI. Because that's also quite costly as well. Right? You don't want to spend another millions of dollars on computes without having a human check before committing a lot of resources to run the research. So having a quick sanity check would help. The other one is alignments. Even though these systems can be very powerful, they can create great results, but are those results that like humans care about or society cares about or would benefit on? Like we may not want the AI to go off its own direction. Just like how when you're running your company, you don't want you want your employees to be aligned to what you want to achieve as a company. You don't want it to go into their own tangents. So having a human in the loop would also help ensure this alignment. So I would say to check for errors, to have a sanity check, so that actually saves saves compute costs and maintains high efficiency. Maybe Google might not have to care about that, but for Sakana AI, we have to care about our compute costs, right? And also to ensure that there's a level of alignments in what the AI systems are doing.
Okay. You recently announced the RSI lab, recursive self-improvement lab, and that's the sort of the cycle of AI building itself. So how should we think about where we are right now, and then why did you launch the RSI lab?
Yeah, great. So I believe that RSI is real. It's like our company, we've started exploring the concept of automated self-improvements 2 years ago. Back then, we didn't actively call it RSI because it sounded more like the science fiction. We call it AI-driven discovery. And this work resulted in AI scientists, AI agents, Shinkai Evolve, Digital Red Queen, and so on. RSI is becoming an important topic now because it's actually starting to work. Anthropic is right. I think they're claiming that Claude is writing 80% of the code for the next version of Claude. And we believe that's this technology should be embraced, particularly in Japan. The direction that Sakana AI is working on RSI is not necessarily the same direction as Anthropic, where they may be looking at RSI at scale, pushing the frontiers of these capabilities. We believe that AI scientists in our RSI loop should be applied to maximizing efficiency, especially energy efficiency in AI use.
But Anthropic has their own model, and the models building the next model. But RSI for Sakana AI, how is it working?
I think the RSI is not necessarily the model building the model. It's the entire technology. I'll give you an example. We've developed a technology called the Darwin Girdle machine. DGM, the Darwin Girdle machine, which was actually quite a popular paper on the back of this RSI technology. Like the core idea is to have the AI agents improve its own agentic code to improve its performance on very difficult tasks like coding challenges and software engineering tasks. So the self-improvement loop is not necessarily confined to the weights, but the entire orchestration of the system, from training, post-training methods, to also the scaffolding of the agents. For Sakana AI, I tell you why I wanted to announce an initiative called the RSI Lab. For us, we've been working on many different research directions in the last 2 years. I want us, part of our team, to focus on pushing the RSI tech direction. So many of our teams working on model building, working on the AI scientists, they're all working focused now on pushing the RSI direction. By having a concentrated team in RSI labs within Sakana AI, it also helps us recruit talents. As you know, the AI talents is very difficult to attract. It's a global market. And having our Sakana AI track record of publication and this focus on RSI allows us to recruit aligned members who want to work on our flavor of RSI. The third reason is our RSI lab is focused, as discussed earlier, on energy efficient RSI. We want to make this technology produce not like the larger and larger model, but more capable, efficient models. And the final reason, we believe that the RSI technology is relevant to Japan's sovereign AI, because Japan does not have the large resources to train massive model from scratch. And it's also difficult to attract all of the researchers to come to Japan. But having the RSI technology enables Japan to develop its own models in a very cost-effective way. So those are the four primary reasons why I decided to put a consolidated effort inside Sakana AI.
Why does RSI enable Japan to be able to build its own model?
I think Japan has several different dependencies in AI. It uses US models, overseas models, open source models. But ultimately, we also want Japan to build its own models. many different companies in Japan are building different types of models for Japan. I'll tell you what Sakana AI is doing when we're building our own models. We're working on pre-training our own LLM model in Japan. The purpose of this model is to be extremely efficient at agentic task. So we're not looking to build the best Japanese language model. We're not looking to build the largest model that knows about all of the facts in the world. We're looking to build the model that is best at agentic reasoning, is best at tool use, is best at is the best catalyst to use for the AI scientists. Right. So the core idea is when we're starting to build this model, our AI scientist technology would also utilize this model to help improve the efficiency to train the next version of this model. So you would end up having this several recursive self-improvement cycles of having this model improvements over time, over successive generations. And the key is to minimize the cost performance of during the training, because I think the pre-training consumes a ton of money and the computes. But if we use RSI effectively, even using other models into our RSI, we can actually minimize the cost of this training loop. I'm estimating that the cost might be 1 to 2 orders of magnitude less than the frontier labs. So we'll see how it goes. This is one of the experiments, an ambitious experiment of using the AI scientist-based techniques to minimize the cost of model developments. And if we succeed, then maybe Japan can start pre-training its own models at a higher scale with a lower cost.
And moving on to the final part, AI companies' winning formula. So finally, I want to talk about business side of the Sakana AI. And I think that you guys work with the like a large financial institution or defense communities and in Japan. And so what are you doing with them? And then how are you leveraging all the research and technology that we talked about today to do the business with them?
Yeah, I mean, our first go-to-market strategy is not releasing the publicly available products. It's really focused on the enterprise business. We chose the finance domain first. So we have many great partners, including Mitsubishi Bank, SMBC, and also folks like Daiwa Securities. Now, why did we choose finance first? I think finance is one of the most difficult areas, and in Japan, one of the highest bar. The tolerance for failure is very low. So if we're able to build, using our research, building the agentic technology and the agentic workflows that add value to the finance sector, we believe this technology can be applied to other sectors as well. And also coming as an ex-Goldman Sachs trader with like 8 years or close to 10 years of experience in finance, I also has an inside view about what matters, what moves the needle in the large financial institution, whether it's risk management, credit risk, or even pitching, writing pitch docs. I work there, and I kind of have my own experience on how to develop this technology. So I also think that's for Japan, it's seen a period from post-deflation to inflation right now. And this actually leads to a lot of change in the finance sector. Banks are actually starting to need to lend money at a faster pace. Mega banks are sitting on a large capital of all of your savings are sitting in the bank. It needs to lend that out. But it's a challenge to hire enough credit risk analysts to work on loan approvals. So one of the projects that we work with Mitsubishi Bank is on AI loan officer, where we're working together with the risk department to assess loans at scale. And hopefully by allowing banks to accelerate the process of approving loans, this can stimulate the economy. So I think these technologies, I wouldn't say they're from the public, they may not seem to be exciting or sexy, but for me, they're quite important because they're addressing the economic needs for Japan. So I think if we're able to succeed in moving the needle for large mega banks, we can apply this technology to several other industries as well.
So are those tools using the technologies that we talked about?
Oh, great question. Actually, many of our own technology is also as a result of being able to work with enterprise customers very deeply as well. So
like a feedback
loop,
each other.
Like I'll give you an example. When we're looking at the loan approval system, the first version of that will be based on the AI scientist paper reviewer. When we're reviewing papers, we have to judge the document and see how good this paper is and write a memo. Now it's a credit memo, not an academic review. Right. So we could use that as a first step and then fine tune it to make it work for the bank. But when we're working with these enterprises on a very deep level, we get insights into our product development as well. We figured out that our ABM-CTS algorithm is especially suited at producing strategy documents and research documents that suits the requirements of large Japanese enterprises, the level of detail that they need. And we use this know-how and our experience to develop Sakana Marlin. So it's a great experience for our company to take our R&D and work very deeply with top Japanese enterprises, understand how to solve these very difficult problems, often requiring tacit knowledge, and incorporating that into our product developments. So I think this cycle is very important and is very different than I would say many Silicon Valley companies that are more developing SaaS product where it's not so tailored. And I think the future requires us to use this technology to solve very deep problems, whether we're working with enterprises, governments, or product developments.
I think you've talked about it as a Palantir style sort of business. So is it like do you think it's like a Palantir and like all the engineers are called sort of the FDE for deployed engineers?
That's one way to think of it for an analogy. I think like our company has several different business lines. One is the enterprise, the other is governments, defense, and the third is the products where we're selling directly to the market. On the enterprise side, I would say you can make a parallel that this is more of a Palantir type business where we're working very closely with the enterprises, deploying the equivalent of forward deployment engineers to customize solutions for them. I think there's a mixed view. My view is this business model ultimately can work in Japan. Now, people always criticize Japan for being like developing software very slowly using SIers and so on. But at the same time, with the rise of AI coding or AI assisted workflow, our engineers are also getting much more productive. Right? So I see the future of this Palantir type model work because our engineers are getting more productive and we're solving problems at scale and customers are demanding more customization. I think actually the rest of the world might be embracing this model as well. Like with SaaS businesses declining and people are like they need more the customization using AI tools. So
because everyone's talking about FDE right now.
Right? So in the end, the silver lining is maybe the Japan's SIR model might be the model for the rest of the world to follow if it's AI augmented.
Right. And you talked about defense and the company is also working with Japanese defense department or the government. But on the other hand, there's been a lot of discussion around the AI companies entering the defense sector. So what do you think, why do you think the area matters for Sakana AI and what's the thinking behind the lines between being what is acceptable or what is not?
That's a great question because now the AI in defense is a heavily discussed topic. But I tell you, when I started this company, one of the core motivations for me, especially like as a foreigner living in Japan, is I respect Japan's culture and values of this country. It's one of the few democracies in the world that actually works, in my view. It's not perfect, but it's a representative democracy in Asia, surrounded by many autocratic regimes. Right. And for me, I think I want Japan to succeed long term, to kind of keep the democratic values and its own unique culture in the world. And when I look at the states of the Japanese government's technology and also the infrastructure in defense, there is a need for Japan to upgrade its defense and government's defense architecture, especially in the rise of AI and this technology being applied to the defense sector. So our company's mission is to develop the AI technology in Japan for Japan. And that includes helping the Japanese government upgrade its own systems and its own infrastructure. One of my concerns, we actually started working in the defense area around a year ago, is that not many companies in Japan are actively working in the government and defense space. And we think that there's a lot of work that we can do to help improve the efficiency. But however, there's a lot of discussions now on guardrails and AI in the military. I think, Japan broadly, defense is defense. It's written in the Japanese constitution that many of the systems are solely used for defense purposes, including autonomous weapons and surveillance as well. That's where we draw the line. We're aligned with Japan's policy on military use and defense. And a lot of work that our company is doing is actually working on, just like with the banks, improving the efficiency of workers. That's somehow maybe working in the Japanese government. It's not necessarily developing autonomous weapons or surveillance systems per se. So there's a lot of work to do in the governments.
So your AI is not going to be an actual fighter?
Our AI, we're currently working on several projects on deploying models within the governments. But so far, we're not working on any autonomous weapons technology or surveillance technology. We stick to improving the workflows of the governments.
Okay. I have one last question. Okay. I was wondering how Sakana AI or Japan itself is making its own way or survive in the highly competitive this AI industry for the next year or next few years. What are you expecting?
Yeah. The AI industry is hyper competitive. I think the US, China, Europe, and Japan is really involved, and India as well is very involved in the process. I think Japan can succeed and must succeed because a world that's developing AI, without Japan's culture, value, and ethics, it will be very lacking, in my opinion. I also think that's the key for Japan to succeed is actually not necessarily having more resources and more talents. I think it's hope. I think that's, in the history of Japan, people always criticize Japan for not changing, but once change is needed, the change will happen rapidly. Once the population has a hope, once we believe that Japan can compete and can thrive in AI, people will do that. Whether it's in Sakana AI or other companies, the innovation will happen to make AI succeed.
はい。というわけで、Sakana AI のデイビッド・ハー CEO をお迎えして、AI はアメリカ製だけでいいのかというテーマでお送りしてまいりました。本日もご視聴いただきありがとうございます。ぜひチャンネル登録と高評価、そしてクロスディグの公式 X のフォローもお願いいたします。さらにニュースレターの配信も始めています。概要欄からぜひご登録をお願いいたします。So David, thank you very much for coming.
Thanks for having me.
Thank you very much.